Chapter 7, Section 7 is about multiplying polynomials. So far in this chapter, we've talked about multiplying monomials, so taking those small individual terms and multiplying them together. And then in the previous section, we talked about multiplying a big polynomial by one single monomial. So now we're just going to extend on this idea, and we're going to be multiplying these bigger polynomials times each other. I'm going to show you two different methods that you can use when you're doing these types of problems. And sometimes students really like one method over the other. And in the future, like after we've practiced using both of these methods, you can decide if you want to continue to use one of the two methods, just depending on which one maybe makes the most sense to you. So in the future, you'll have a little bit more freedom to decide like which method you want to use. But for right now, I am going to show you how to do both, and it's important that you're able to practice both, just so that if you have to use one of the two methods in the future, you know how to do that. So for the first method, we're going to kind of keep it like what we've been doing previously with our sections, and that was using the distributive property. So method one is to still think about distributing. So what I'm going to do is take this 3x from this side here, and I'm going to distribute it through. So I'm going to draw my sets of arrows, all these terms over here. So we're taking this monomial, 3x, times this big polynomial. So you're taking 3x times 3x squared, which would be 9x squared, x cubed. Then you're taking 3x times 2x, which would be 6x squared. And then 3x times negative 8 would be negative 24x. Now, we also have this plus 4 that we have to take care of. And so we're going to distribute a second time. And I like to draw another set of arrows, and I do them underneath my problem. Okay? So 4 times 3x squared is going to be 12x squared. 4 times 2x is going to be 8x. And then 4 times that negative 8 is going to be negative 32. After you've done your double distributing there, you then want to look at your new sentence that you have, and you want to combine your like terms. So I take a look at the first one, which says 9x to the third, and I look through my list here, and I don't see any other terms that have an x to the third power, which means I can't combine that with anything, so I'm just going to drop it down. Then I look for my x squared, because I'm trying to put it in descending order. So I take 6x squared and 12x squared. So I add those together, and that would be 18x squared. Then I look at my x's. I've got negative 24x and 8x. And that's going to be put together a negative 16x. And last is this negative 32, which doesn't have anything to go with, so I just drop it down. And here's my answer. Now, the second method is called the box method. And what I like about the box method is that I feel like it helps keep things a little bit more organized. If doing a lot of arrows like this in that first problem is maybe overwhelming to you, or it's hard to keep track of the things that you're supposed to be multiplying together, then you might like the box method a little bit more. To get yourself started with the box method, you're going to take the first polynomial. In this case, it's a binomial, because it's that 3x plus 4. And we're going to stack those on top of each other. So 3x and then plus 4. And then I draw a line to separate them. Then I take the second polynomial, that 3x squared, and the plus 2x, and the minus 8. And then I draw lines to separate those terms. So you can see how I've kind of created these boxes. This one is more of a rectangle-shaped box. It's not really a true square, but that's okay. And so now what I do is I look at my terms in like the columns and my rows, and I start multiplying these, because now they're just like individual monomials that I'm trying to combine. So like for the first one, I'm taking this 3x times this 3x squared, and that's what's going to go in this first box. And so that would end up being 9x to the third. If I go across the top here, 3x times 2x would be 6x squared. And then 3x times the negative 8 would be negative 24x. And if you notice, these three terms are the exact same three terms that I had over there. So I'm doing the same process. I'm basically distributing. It just looks different because it's put into the boxes. So now I'm going to do that on the bottom here. 4 times 3x squared is 12x squared. 4 times 2x is 8x, and 4 times a negative 8 is negative 32. Now another thing that I find kind of handy about the box method is that most of the time, especially if the polynomials that they're giving you are already written in descending order and it doesn't skip over any terms, your like terms are going to be next to each other in your problem here. So that 9x to the third, I'm going to go ahead and just drop that down, because there's nothing that needs to get combined with 9x to the third. And if I look at my x squareds, these are diagonal from each other. So 12x squared and 6x squared together would be 18x squared. Then the 8x and the negative 24x, those are going to get grouped together because they're like terms, and that would be negative 16x. And the last term we have is that negative 32, and that's just going to come down. As you can see, I got the exact same answer that I got up above, just using that separate method. So for right now, I'm going to give you a practice problem, and what I want you to do is do both of these methods. I want you to practice both doing the double distributing and doing the box method. So this might take you some time. You know, it could take a good 5 or so minutes for you to get through both of the methods. So I want you guys to pause your video, try to do both of the methods here, and then resume watching so you can see how it should have turned out. So for the first one, I'm going to double distribute. So I started by taking my 2x times everything. So that comes out to be 6x to the third. Then 2x times the negative 4x is negative 8x squared. And 2x times 5 is 10x. Then I needed to distribute another time. This time, though, you are taking negative 3 times everything in that second set. And so that came out to be negative 9x squared plus 12x minus 15. Now I look for my like terms. 6x to the third is the only x to the third I see. Then I look for my x squareds. I have an 8x squared and a negative 9x squared. So that's negative 17x squared. Then we have 10x and 12x, which is 22x. And last is that negative 15. That goes down below. Now, when you do the box method, you should end up with the exact same terms. So you should get everything inside the box to match the terms that you wrote out here when you were doing your distributing. And then when you combined your like terms, you should have also gotten the exact same answer that I just got when I was combining my like terms together. So I'm just going to fill in my box here real quick. I'm going to make sure that my colors kind of match so you can see what should have been together. So you can see how those three match my first three over here. And then the bottom 3 should match the last 3 that you had when you were distributing. Then I look for those like terms. So I had 6x to the third. The negative 9x squared, negative 8x squared gives me again negative 17x squared. 12x and 10x gives me 22x. And then last is that negative 15. So now that you've seen both methods, hopefully you have one that maybe you prefer, or that you at least think is a little bit easier for you to do or more manageable. And so as we get going in these next couple of problems, you can decide what method you want to use. So if you want to keep using the distributive property because you're so used to that, that's fine. If you really like the box method that I've shown you, you can use that method too. Now, as I go forward, I am going to use the box method because I prefer that method out of the two. And I also just think that the box method is easier for especially like this next example. And the reason why I think that is because on this one, you're taking a trinomial times a trinomial. So you have 3 terms times 3 terms. If I were to do my distributing, I would start by taking the 5x to the third times everything over here. Then I would need to take the negative 2x and distribute. But I'm not quite done because I also have this plus 7 that I would have to distribute again. Now, it wouldn't be terrible for me because I'm kind of at an advantage here of I've got all these different colors that I can use, and so that helps me kind of keep track of what I've been multiplying and doing. But for some of you, like, that's really overwhelming to see all those lines, especially if you're writing this out in pencil, because then your lines kind of start to blend together. It gets confusing. You're not sure what you've done and what you're supposed to do next. So I gravitate towards the box method for these types of problems just because I do think it makes it a little bit more manageable. So for my box method, I take the first polynomial, and I do that one up and down. And then I do the second one across the top. Got my lines in here. And now I start multiplying my terms. So 5x to the third times 3x squared is going to be 15x to the 5th power. Across the top, 5x to the third times a negative 4x is going to be negative 20x to the 4th. And 5x to the third times 6 is going to be 30x to the third. Then I'm going to do the next row here. So negative 2x times 3x squared is negative 6x to the third. Negative 2x times negative 4x would be 8x squared. And negative 2x times 6 would be negative 12x. Then I'm going to take 7 times all those terms across the top. And so I get 21x squared, negative 28x, and then 42. Now when I start looking for my like terms, some of these are a little bit more scattered than we saw on the previous examples. And that's because my first polynomial that they give me starts with x to the third. It skips over x squared, and then it just goes to x. So we're missing a term in the middle there. So it's going to kind of cause this to jump around a little bit more and not be necessarily all diagonal. But that only really affects like the first couple of terms in our problem. Like we're going to go ahead and take that 15x to the 5th and write that first because there's no other x to the 5ths here. Then we're going to look at that negative 20x to the 4th, and that's going to come down as well, because there's no other x to the 4ths. Now, my x to the thirds, I have the negative 6 here, and I have 30 there. Together, those are going to be 24x to the third. For my x squareds, we're going to add those together, and so that comes out to be 29. X squared. My x's are diagonal now from each other, negative 28 and negative 12, which would be negative 40x. And then last is that 42. And there's your answer. You could have used the distributive property on this one like I showed you with all those arrows. And if you did that, that's fine. If you don't really like the box method, you don't have to use the box method. I'm going to give you guys a chance now to practice. Again, this might take you a little bit of time, so I would encourage you to pause right here. Try to do this either using the distributive method or using the box method, and then come back and keep watching to see how I did it and what you should have gotten for your final answer. So when I did this problem, I used the box method just because I stated earlier that that's the method that I prefer. So when I did this, my box is filled in as so. I had 8x to the 5th, 6x to the 4th, and then negative 18x to the 3rd. That was across the top. The next row here said 12x to the 4th, 9x to the 3rd, negative 27x squared. And for my last row, I have negative 20x squared, negative 15x, and then positive 45. My first term I need to write down is that 8x to the 5th. That's the leading term because it's got the highest degree. My x to the 4ths are right here, and those together should have been 18x to the 4th. My x to the 3rds are diagonal to each other right there, and that left me with negative 9x to the 3rd. My x squared terms are a little bit more spread apart, still kind of diagonal from each other, and those together should have given you negative 47x squared, and then the last two terms just need to come down, negative 15x plus 45. Now, these next couple of examples are going to show you a shortcut that we can use when you're taking a quantity and you're raising it to a power. And specifically, we're going to be talking about raising it to the second power. So we're going to be squaring these quantities. Now, we're talking about binomials when we do these types of problems. Binomials mean that they have two terms. And so we're going to be taking the same quantity times itself. So if you see something like this first example that says x minus 5 squared, what that really means is that you're taking x minus 5 times x minus 5. You're multiplying it times itself. It's the same thing if I had 4 squared. That would be the same thing as 4 times 4. So it's the same idea that we're using here. What you can do is you can set up the box method again here, or you can use the distributive property. Since this one's a little bit smaller, I would say that the distributive property is probably an okay or easy way to do these types of problems. If I'm doing that, distributive property, what I'm going to do is take this first x and multiply that in to the second quantity. So x times x would give me x squared. X times negative 5 would be negative 5x. Then, for the second quantity, we're going to take negative 5, and we're going to distribute that in. So negative 5 times x would be negative 5x, and negative 5 times negative 5 would be 25. You'll notice when you do these types of problems that there's only two like terms, and those are right there in the middle. So I have x squared coming down. In the middle, we're going to double it because it's the same. So it becomes negative 10x, and then we bring down the plus 25. A shortcut that you can think about for these types of problems is you're squaring the first term, that was x squared. You're squaring the last term, which got me positive 25. And then you're taking the x and the negative 5, and you're basically smushing them together. You're putting the number first, and then you're doubling that to get your middle term. So if you see kind of those connections, that'll especially be helpful as we get into the next chapter and we start talking about factoring. But that's just something that you might start to notice when you see some of these more special cases. Go ahead and take a minute and do this problem. So for this one, if you needed to write it out so that they were side by side, 2x minus 6 times 2x minus 6, and then you can do your distributing. You should have had 4x squared minus 12x, and then you take that negative 6 and you distribute a second time, and that should have given you negative 12x, and then plus 36. These together then should say 4x squared minus 24x plus 36. The last couple of problems that we're going to see here in this section are going to use order of operations within our polynomials. So we're going to be kind of combining like everything that we've talked about so far. We're going to be adding and subtracting polynomials, multiplying polynomials, and combining like terms. So we're doing pretty much everything that we've seen in the last 4 sections here, where we're combining kind of all these properties that we've been talking about. Now remember with order of operations that if you see brackets or like parentheses in that all of that stuff needs to get done first that's inside those brackets. So on mine, I've got these kind of hard square brackets. I need to take care of this big piece of information first. So what I do is I need to subtract it. Now if you remember with subtraction, I talked about how you want to take that negative sign, think of that as like a negative 1, and you're going to want to distribute that in to everything over here on this side. So I'm going to bring down this x plus 3. I don't want to do anything with that quite yet. And then inside here, I'm going to remove the parentheses from the first polynomial. And then I'm going to take everything in the second one times a negative 1. So they're all going to switch their signs. Now, on the inside here, I'm going to look for like terms. So I see an x squared and a negative 3x squared. I see a 2x and a 5x. I see a negative 5 and a 7. And so those are going to be my like terms that I'm going to want to combine. So again, I'm going to drop down the x plus 3. And then in here now, x squared and the negative 3x squared would be negative 2x squared. 2x and 5x would be 7x. Negative 5 and 7 would be 2. Now we're back to what we saw at the beginning of this section. You can either use the distributive property or you can use your box method to finish this one off. So if I start multiplying, whether you're distributing or you're using the box method like I am, you should get the same terms in here. So I get negative 2x to the third, 7x squared, and then 2x. And then down below, I have negative 6x squared, 21x, and then positive 6. And then if I try to combine my like terms, I'm going to have a negative 2x to the third, an x squared when I combine these two together, a 23x, and a plus 6. So nothing new as far as the things that we had to do. We've done all of these things before. We've added and subtracted. We've multiplied polynomials, and we've combined like terms. So I'm just taking all the things that we've been doing recently and applying it to one big problem. So you should start to see those connections between being able to do all these different types of operations with these polynomials. I want you to go ahead and take a minute or two and try to do this problem. Again, this might take you a little bit of time, so pause your video and then come back and keep watching to see how it should have turned out. What I did first is, again, I focused on the inside here because it's inside those big brackets. And so I brought down the 2x minus 3. And then inside these brackets here, I added my like terms. And so that gave me a 7x squared minus x plus 10. Then I went ahead and set up with my box method again, or some of you may have used your distributive property twice. So we have 14x to the third, negative 2x squared, 20x, negative 21x squared, 3x, and negative 30. The 14x to the third needs to get brought down because there's no like terms for that one. You've got a negative 21x squared and a negative 2x squared. So that should have been negative 23x squared. 3x and 20x should be 23x. And then last is that minus or negative 30. And that needs to just get dropped down. And there's your answer.